Hi, one of our students asked about problem number 36, and you can see got part of the answer wrong. And so I decided it would be really good to go over this with you. You're going to have to use your graphing calculator. Doing this by hand the old-fashioned way will get you the right answer, but it will take you half an hour. I mean, why spend that much time when a graphing calculator can do this for you very easily? Okay, so notice this says graph the system of inequalities, then find the coordinates of the vertex. Well, here there's only one vertex. They say vertices because it's not uncommon for these systems to have more than one vertex. But we only have one vertex, so we'll graph one vertex. So here we have an inequality. 3y minus x is less than or equal to 3, and y plus 7x is greater than or equal to negative 3. I'm going to graph both of these in my calculator, and so notice that I came over here and I put each one of these into slope-intercept form by solving for y. Now I'm going to get my calculator and I am going to graph the lines. Go to y equals 1 divided by 3x plus 1. That's the first one. Y equals 1/3 x plus 1. I'm going to graph that. Just let you see what this looks like. Inequalities are always shaded. They include the line, right there, the line, which when you're dealing with inequalities is called the boundary, and you're dealing with the shading. Everywhere that's shaded all the points in this shaded area will give a true answer to our inequality right there and to the original inequality. Okay, now let's do this one. I'll go back to y equals. I'll go down to y2. And I'm going to graph negative 7x minus 3. Remember that the negative button and the minus button are two different buttons. Now I'm going to graph y2 on top of y1. Where the red and the pink overlap, where the red and the blue overlap, which is kind of a pink, a deep pink, this is the shaded area you're looking for. This is where the overlap occurs, and as you can see, this is the yellow region over here. Okay, so we agree with this area right here. We agree with the graph, but how do we duplicate that? I need to make this graph appear. Okay, so here's how it would be done. Go back to y equals, come down to y2, and go over to the equal sign and hit enter. Notice the highlighting is off the equal sign. That means that when I go to my table of points, I will only see the points for y1. So, second, graph. Wrong. Second, graph. There we are. There's our list of points. I can choose any point, but I might as well choose some of the easier ones. So if I was graphing this from scratch, I would definitely choose the point 0, 1. And I would graph that first, the point 0, 1, and then I would go to the point 3, 2, 1, 2, 3, 1, 2, and graph that. So I would graph this point, and I would graph this point. Then I need to graph this line. So I would go back to y1. I would go to the left and hit enter, take the highlighting off the equal sign there in y1. Then I would come directly down to the equal sign in y2, hit enter. Now it's highlighted. I go second graph. And there are the points for y2, which is this line right here. Now, there are a bunch of easy to graph points here. Let me see, I'm going to go up. There we go. Because I have to look at the grid. Where can I actually graph points? The point 1, -10 would be out of reach. Yeah, it would be. That would be down here, and I wouldn't be able to get to it. So I need something I can actually reach. -1, 4 would be perfect, and so would 0, -3. So then I would go -1, 4, and hit click, and then I would go 0, -3, and hit click. I would save my answer. I would hit I would also, having looked at the graph, let me go back to y equals. I'm going to go over to the equal sign in y1. I'm going to hit enter, and now I draw your attention over here to this lower triangle. How did I get that? Well, originally, your calculator will do this. It'll just look a little different. Originally, this is what I had by the equal sign right there. You have this too. It's just a straight line marker. But that won't do me any good because I'm dealing with an inequality. I need less than or equal to. Well, a down triangle is the same as less than. And you'll notice that if I hit enter, now you're not going to get a little box like that, probably, but you will be able to flip through some markers, and you'll finally come to a lower triangle, which means less than, and I'll hit, no, I won't hit OK there. I will come down to where OK is boxed in and hit enter, and now I have a lower triangle. Now, because y2 is greater than, I have an upper triangle. And that's how I got my shadings. So now I'm going to hit graph just so I can remember which area has the overlap of the shading. I would drag the little paint bucket icon to this area over here, drop it. It would shade this area automatically. Wherever you drop the bucket, that area gets shaded. And then I would click check my answer, and it would tell me, that's perfect, that's wonderful, that's great, whatever it is that my math lab says. Okay, so we would have graphed this part of the graph, and now we have to find the vertex. All right, I'm going to take away this, and we're going to get to work here. Because when we're finding the vertex, we're just dealing with the lines, or as we call them when we're dealing with inequalities, the boundaries. but they're just the lines, not the shading part. And so, as I look for my marker and can't find it, I am going to use, here it is, okay. I am going to change each of these inequalities to y equals 1/3 x plus 1 and y equals negative 7x minus 3. And now I have a system. I have a system of two lines. And how do we solve systems? We use substitution or elimination. You can do either one, but considering that we have y solved for in both of these, it would be very easy to use substitution. I could take this down here and put it in for that y right there. In fact, I could do something even easier. Since this line is this line, notice this line has a fraction, which makes it harder, but this line doesn't, so I can actually take 3y minus x equals 3 and plug this y in there. So I'll take 3 times negative 7x minus 3, that's 3y, minus x equals 3. That will be negative 21x minus 9 minus x equals 3. Negative 21x minus 1x is negative 22x. And I still have a negative 9 there. Equals 3. Add 3 to both sides. Add 9 to both sides. These will zero out. I'll have negative 22x equals 12. Then I'll divide by negative 22, divide by negative 22. And I'll have x equals negative 12 over 22, which is negative 6 over 11. And that's what x equals. Now, what about y? Well, we have two equations that are solved for y. We can use either one. I think I'll use y equals negative 7x minus 3, which will be negative 7 times negative, there we go. All right, we'll come up here. Y equals negative 7 times negative 6 over 11, that's x, minus 3. This will be y equals negative 7 over 1. Here, let's move that down here. Y equals negative 7 over 1 because we're multiplying by a fraction, times negative 6 over 11 minus 3. That will be y equals negative times negative is positive. 7 times 6 is 42 over 11 minus 3. Did I say negative 42 over 11? I meant positive 42 over 11 because our negatives canceled out. Now, you can do this by hand or you can do it with the calculator, and it's pretty nifty how the calculator does this. So let's go back here. And I'll turn it on and I'll go second quit. That'll give me a blank screen. And now what I'm going to do is I'm looking at 42 over 11 minus 3. Okay, now I am going to have 42 over 11 minus 3. So I'll say 42 divided by 11. That's 42 over 11 minus 3. Now if I hit enter, I get an ugly fraction. But if I say math, frac, enter, I get 9/11ths, and that indeed is the answer for y. So I have now found the ordered pair, -6/11, 9/11ths, that go right there. The point of intersection, the solution of the system of lines. Only here we call it the vertex of the system of inequalities. And no, it's not a vertices, that's the plural. That's an error on the part of the publisher. It's one vertex. Okay, talk to you later.